Hi friends, welcome to our channel. Let's have a look at problem 3565, Sequential Grid Path Cover. In this video, we are going to solve the problem using recursive backtracking. So we are not going to read through the problem statement, but we want to make a comment. So here it's not required to visit the cells with values from 1 to k consecutively. As long as the visit is in order, that would be fine. So this is corresponding to this cell, this bullet point. So before we do the coding or explain the idea when we do the coding, let me first do a size estimate. So here the grid just less than or equal to 6 in row, not same in column. So therefore the number of cells in the grid is bounded above by 36, right? So now each cell has at most 4 directions or 4 neighbors to visit, and therefore the number of different paths covering all cells is bounded by 36 to the power of 4, right? So this is roughly 1.6 million, right? So from the size estimate, we can see that a recursive backtracking to construct the path might work. So that's actually some intuition we have. So now let's look at the problem using backtracking. So I'm going to explain the logic when we do the coding. First, we want to get the number of rows and number of columns. This will be the length of the grid and the length of grid 0, right? And also we know there are 4 directions, so we can use this to do the 4 directions. So 0, 1, and 1, 0, and negative 1, 0, and positive 1. So let's see. So positive 1, negative 1. So 0, and then we should have 0, negative 1, right? So basically, if the first this corresponding to go up, right? So if in coordinates, but if you in the column, it's going to go to the right column. So let's go to the say the downside row. Let's go into the opposite row. Let's go to the left column, right? So then we also initialize a path variable. So this is a list. So we are going to construct the path satisfying the problem requirements. So what we want to do is a standard backtracking. So we're going to have backtrack. So we have a row, we have a column, and we have a number. So the row and the column is the coordinates or the cell position we are going to visit next. And then the number, so if the number is in between 1 and the k inclusive, so this is the if the cell contains this value, a value, it must be if inside this 1 to k, it must be this number or the number we need to have. So if you have visited a position with number 1, then the next position to visit you should have number visit to be 2, right? if the cell contains 1 to k, right? So this will be the major thing. So let me make some comment. So here this function the construct the path. So it does 2 works, 2 things. So one is check if there is a valid path starting from the state row, column, and number, right? And actually simultaneously it will modify the path variable. So the path actually is a mutable thing, right? We don't need to use the non-local path if we want to modify that. So this is special for Python. So now with that we can, so the return would be a boolean, right? So basically this will be an integer. So this will be an integer, and this will also be an integer, and then the return is a boolean, right? So corresponding to this one. So first, the cell we're going to visit is grid, row, and column, right? So then if we have visited a cell, we're going to modify its value to be -1, right? So then if a cell is equal to 1 with a value 1, it means that we have already visited this one. Or if the cell is not 0 and the cell does not equal to the number, so this cell is what we are going to visit. So if the value is in between 1 and k, it should be equal to this number, right? If it does not equal to this number, so we're going to return false. So this is the one check or one bounding condition or stop condition. So if after this if, we can actually add the current cell to the path. So now we are going to check if we can return. So if length of the path equals to m by n, it means that we have visited every cell, and also because of the logic you are going to see, we also visit those cells in order. So we are going to return true. This is the one. Another one, if cell equals number, right? So if currently we are visiting the cell that is number, right? So next cell, if has a value in between 1 and k, it must be in this equals number plus 1. That's why we increment number by 1. So because we have already visited this current position, so we're going to set grid, row, and column to be -1, right? And then the main logic is the following. So for dr, dc in directions, right? So the new position would be r plus dr. So let's see, row plus dr and the column plus dc. So now what we want to check is if this thing is inbound, so it's less than m, and c less than n, right? And also if we can successfully find a path, so from the current position, then num. Notice that this num has already been incremented by 1, right? So if this is the case, so we return true, right? So if nothing has returned of this for, we need to continue the process. So now let's do grid, row, and column, so equals cell. That also explains why we first have this one, or we need to recover the previous state. So recover the previous state actually contains two things. One is set to be the original value, and then pop the cell from the path, right? So if up to now and after this for loop nothing returned, so we need to return false. In other words, there's no such valid visit or traversal from the current state. So with that said, I guess we finished the main logic. So now let's look at the problem logic. So for row in range m, for column in range n, then we are going to use this row and the column as the start position, and to see if grid, row, column is greater than 1, we don't need to visit, right? We cannot start from here, so let's continue. Then we want to check if backtrack from the current row, current column, then we should start from 1, right? And then if this is true, so we don't need to continue because we have already found 1. But if we call this function, so this path will be modified, right? So here we can break, and then we just need to return the current path state. If no such path, we're going to return an empty array. In other words, if in this for loop, so we finish all the loop, but it's all return false. So we just return the original state that will be the empty one. If there's a valid path, this return will have the valid path. So before we make a further comment, let me first run it. List object has no add, so here I guess path should append. So if you just set, so you have this add. Yeah, it passes the two test cases. Now let's look at the generic case. Yeah, it passes all the cases. So now let me try to analyze the first one, because for the second one it's rather special because there's no valid path. Therefore, we just empty and put it empty. The first example actually demonstrates that the valid paths are not unique. For example, the expected, so this way is the same, but if I modify the order of the directions, so let's change this one. Let's put it here. Then the output and the expected might be different, but still pass the requirement. So this still the same. So now let's still modify a little bit. So let's change this to be 0, -1, -1, 0, and 0, 1, and +1, 0. Let's run it again. You see here it's already different, right? So the output, we first visit 0, 0, and then 1, 0, and then 1, 1, and then go up to 0, 1, then visit this 0, 2, and then visit 1, 2. But the expected is a different path. So visit 0, visit 1 and 0, 1, 1, and then we first visit 0, 1, 2, and then go up to 0, 2, then to 0, 1, right? This actually demonstrates the non-uniqueness of valid paths. So that's one thing. Another thing is that so for this problem, the recovering of the state actually has two lines of code. So one is that we need to recover the value of the grid in this position, row and column, and also we need to recover the pre-state of the path variable. So that's why you have the two lines. So typically, if you look at other problems not in this setting, maybe you just need to do a path pop, right, without need this line. So this is the detail you need to notice. So we have actually a playlist on these traversals. You're welcome to check out those in my channel. With that said, I guess that's it for the current video. Thank you for watching.